thing that all high school students loathe. Hey, you must be wondering why I'm here. The truth is, I got a B in my algebra test. And in the Asian scale failure, that is unacceptable. Actually, that's kind of okay, but still I need to get into a group. So, in order to increase my grade, I made a deal with Mr. S. So, according to my contract, I have to contain half of what I know about Algebra 2 in this quarter into the presentation, and I have to turn it in by next Thursday. Oh God. So, I guess we gotta get this coming. Oh God. We'll be starting off with level 1 of Algebra 2. Algebra 1. The thing is, this level is basically just a review session. You should have known this by now. But, this is mandatory because I went through it. So, we'll be starting up with linear equation. The linear equation is basically just a line. It follows a slope and it creates a line on a graph. The linear equation has two basic forms. The first one is the standard form, which is basically useless and teacher would just use this to tease you, and it's only usable in other forms. The second one is the actually important one, the slope-intersect form. This is very useful because it maps up the slope for you. A graph or a line follows the slope. The slope can be got through delta y over delta x, which is rise over run. To map a linear graph, you just plug in 0 and x and y, and then find the value, which is the x and y intercept. You can use these 2 points to map the line, or you can just choose random 2 points, but basically, the most usable form is that. You just use the x and y intercept. It can make straight lines, slant lines, vertical lines, reverse slant lines. Next up, we have linear inequality. Linear inequality is basically the same from a linear equation, but they have a union now, and now we have to satisfy their needs. So, linear inequality is different from linear equation because it has signs that determine where they want to go. So basically, you do the same thing and map the line. And then you plug in 0, 0, or any other number to find out which one they belong in. If that doesn't satisfy the equation, then you just switch sides like every other person would do when something doesn't work. Also, there's a non-existent line now, because if it's not equal, it isn't solid, it doesn't exist. If it is equal, you have a solid line. It exists. You also need to switch signs when you multiply the equation by a negative value. Did I forget to mention that when you multiply the equation, you can just switch it. You can change the equation by adding a certain value to both sides of the equation, or minus or divide. You get the point. If you divide by a negative value, or multiply by a negative value, you will have to switch sides of the equation. So, next up we have absolute value. Absolute value is a V, because it has no negative emotion inside. Basically, absolute value is a therapy session that allows all negative numbers to be positive. In the equation, there will be 2 forms of it. The first form, the entire thing is encased in the absolute value. That thing is easy. The second form is not so easy. It's this. You can both solve them when the absolute value part equals to 0, which means in the first equation, it's equals to y equals to 0. In the second form, it means y equals to c. And because of c, in the second form, you can go into the negative zone. And also, the thing can be inverse due to a. Next up, we have 2 systems of equations. There's 2 equations now. The thing with 2 systems of equations, there are 3 ways to solve it. The first way is graphing. It's utterly useless. You just draw 2 lines. But the thing is, it doesn't work when the numbers are super messy. So, basically the first form is ruled out of the question unless your teacher asks you to revive it. The second form is kind of useful. It's substitution. You first find the value of one of the variables, and then you use the value to substitute it in another equation. Basically, you'll get the value of one of the variables, and then you plug it back into the equation to find the value of the other one. And the third form is elimination. My boy, this is the best way to do it. In my opinion, that is. You can use substitution if you want to use simple. The third form asks you to kill the other variable. So you match two of them and then get them to amount the same frequency, and then you minus them together or plus them together to cancel one of the variables out of the equation. Now, once you cancel those equations out, you can have one of the values, which is what you want. There can also be infinite many solutions when the two lines are the same line and you just have to find it. And another way of doing this is no equations when they're having the same slope. You have exited your cradle, now you're facing level 2, the start of your suffering. The first thing in this level is free system of equations. And free system of equation is kind of the only thing too. And it's so dang infuriating! Free system of equation is very similar to two system of equations. But now there's Z. Hello! Shut up! Hello! The addition of the third variable makes everything very complicated. First off, graphing is dead. It doesn't work anymore. So the first method is substitution. Substitution still works the same as it does last time. But now, since there's Z, it's very complicated. You have to care about where you move first, or you'll have to revert everything back to its original state. It's very frustrating. The second method is my boy elimination. They nerfed elimination. It doesn't work as good as it does. Now, to actually solve it, instead of doing it one time, you have to do it 4 times consecutively. And it's going to be very complicated. And because I have a dumb brain, it always gets too complicated. So, to actually be able to solve this fast and accurately, you need to learn matrices. Furthermore, the order of elimination is actually very important now, for you can actually get stuck inside an infinite loop. And also, the best way to deal with these is you use the two methods at the same time. It's going to be much less of a hassle if you just reduce these two to 2 linear equations and then plug them back in. But, still, it's a hassle to deal with all 3 of these equations at the same time, no matter the method. So, to actually deal with this efficiently and fastly, you have to use matrices. And also, there is also another possibility called no unique solutions. It's when these 3 lines form a triangle and don't intersect on one line. It doesn't really appear on tests that much, but still, it's really important to remember this thing. Next up, we have matrices. What are matrices? Matrices is those things that you see in the computer. It's basically a graph. It's commonly used in computers. It can be added, multiplied, subtracted, but there's no division. Division is dead in this one. Rule 1. Matrix addition and subtraction can only be done with 2 matrices of the same size. Rule 2. Matrix addition and subtraction and only affects numbers at the same coordinates. You only need to add them together at the same coordinates. Rule 3. Matrix multiplication is taking one rule and multiplying it by another column, then adding them together. like this. You can multiply two matrices of two different dimensions, but the amount of rows in matrix 1 must be equal to the amount of columns in matrix 2. Then we arrive at determinant calculation. Determinant calculation can only be achieved by a matrix with square sizes. And it is super complicated. For a 2x2 matrix, it's AD minus CB. That's easy, right? Now you have to face the monster of 3x3 determinant! The 3x3 matrix is bullshit. It is basically a hard mass that is bullshit. It basically goes like this. I'm leaving. What? Oh god, no! It is basically this. So first, you go with a slant line from left to right, and then you combine them together through multiplication, and it remains positive. The second time, you combine D, H, and C, multiply them together and add it together. And the last time, you combine the last three variables, multiply them together, and then add them together. You think that's done? No! Now you have to tap into the shadow realm and reverse it! And then you have to offset them to negative, and then you get this hell of a mess. This is really messy and complicated, and why did you teach this us? Oh god, why, Mr. Shen? The second method is relatively more manageable, but it's still infuriating! So, basically, TLDR, you grab the first number in the matrix, eliminate its row and column, and you'll get a 2x2 matrix. You solve it, and find the determinant of it, and then you multiply it by the number and column you choose, and then you got the first number. Repeat that procedure with the second number, eliminate its row and column, and then solve it, and then this time set it to negative, and I do the same with the third number, but set it to positive. And you'll get something relatively more manageable like this. Now, how do you solve system of three equations with it? Let's just throw that all away and let's still do two systems of equation again. So first, all you need to do is you translate the standard form into a matrix. After you translate it into a matrix, find the determinant of the matrix. We'll call it the original matrix. And then you find the X matrix, which is you replace the first line or the first row, no, the first column of the matrix with the results of the linear equation. After you replaced it, you'll get a new determinant to calculate. You calculate that, and then you divide the new determinant by the old determinant, and then you get x, the value of x. And then you do the same thing with y, but now you replace the second row. To be fair, I don't know how this works, but you can solve x and y like that. So do you know what's coming next? You have to do that by 3x3 equation! You have to calculate the 3x3 determinant 4 times! It's going to be super hard, but trust me, just doing this under pressure is going to be way easier than trying to think how does those three other methods work. And plus, those 3x3 and plus, your teacher will definitely torture you with this. And also, to actually solve this, if your determinant equals to 0, that means that it has no unique solution, which means that thing is 3 triangles, but you still have to solve it because you have to determine if it's infinite many solutions or no unique solutions. But guess what? We're still not done with that. This is the last thing in this level. Finally! Remember that I said that matrices doesn't have division. Wow, that's because instead of division, we have inverse matrix. To calculate the inverse matrix, you have to first find its determinant again. We're not going to do 3 by 3 because Mr. S still haven't teaches it to us, and plus it's in calculus territory. I can't do calculus yet. Oh my god, I have to do calculus. Inverse matrix cancels out the normal matrix. So, to inverse a matrix, you find its determinant. After you find its determinant, you put it under a fraction. After you put it under the fraction, and then you just twist the original matrix by swapping A and D, and making B and C minuses version of themselves. And then you got the inverse matrix. Normally, these kind of problems will appear when the x is attached to a matrix, so you just multiply both sides using the inverse matrix, and then you'll get the thing. And then you solve the matrix using normal shenanigans by finding by division, addition, and etc. And then you find how it works. And that's about level 2. Finally, 3 by 3 matrix is hell. But wait! There's level 3, baby! Now, we're stepping into a new horizon because now the equations have powers, strength, those small hyper things. Because of those, we're now stepping into a new realm of quadratics. Goodbye linear equation. This is supposed to be harder. But 3 by 3 matrix, in my opinion, is way harder because of all the numbers you have to crunch. Here are a few differences from the normal linear equations that we're used to. First off, standard form is now useful now. And also, there's 2 x's. So you have a squared x and a normal x. And this is the new standard form. This is really useful. You use negative b divided by 2a to find the vertex, the center point of where the curve is happening. And also, this kind of echoes with absolute value, but absolute value is linear. This is quadratics. Now, the domain is the restriction of x, and the range is the restriction of y. And here are all the restrictions. But, here's the thing. If you want to find out where the vertex is, you need to plug the number that you got from negative b divided by 2a and then plug it in back into the equation. And then you'll get the other thing, which is the vertex. The thing that I just told you, negative b divided by 2a, is technically the line of vertex, or whatever it's called. It's a line that's useful, somehow. And also, now there's slope-intercept. The slope-intercept form has upgraded into the vertex form, but it's practically unused in practical calculations, like solving for the zeros and other things. So, wow, how the terms have tabled. Now we know what is quadratic. Now we can do quadratic factoring. Quadratic factoring is the fastest method, but it requires some number sets, and sometimes if you don't know how to do it, it's best to brute force it. So first, to get the results you need, you have to remember this only applies when the standard form equals to 0. So you have to factor these two and turn it into the table of numbers, and then after that you use those numbers to try and find b And then after you find B, you just plug it in as zeros, and then you find out what is the reverse, what makes those x zeros. Do you understand? This is the fastest way that I can understand this. Here's a note. If b squared minus 4ac equals to a perfect square, then that is factorable. I'll explain why later. Completing the square is kind of like that thing that you want to hate, but you can't hate it because it actually works. So, in its prompt, normally you'll get this. This is basically an incomplete complete square. So you have to complete the square. So you add both sides and make them into the classic a squared plus 2ab plus b squared format, or the normal times when a comma is squared. So you get this format, and then you reverse it by square rooting it, and then you do that. Sometimes an illegal operation will pop up, because sometimes the negative number will be inside the square root, and that is bad. Do you know why that's bad? When there's a negative number in the square root, that's not supposed to be happening. That doesn't exist. That's why there's a new thing called imaginary numbers. It's a figment of your imagination. It doesn't exist. It never have, and it will never will. It doesn't exist. Here's a graph of what we're dealing with. This is real numbers. 99% of the numbers. Now we have imaginary numbers. This doesn't exist. Where did it go? Who knows? Negative cube root doesn't exist, and that's I. So we just basically take that out of the equation, and we now have a positive number in our root. Still, the number doesn't exist. After we solve it, we might get something like that. That's complete the square. And this is the last thing that I need to mastery. The last thing is the quadratic formula. The quadratic formula is simultaneously the fastest and the slowest method out of the two methods I just talked about. The quadratic formula follows this. X equals to negative b plus or minus square root of b squared minus 4ac divided by 2a. That's the whole thing. You must be wondering, wait, this looks familiar. If this place is a perfect square, that means this is rational number. With rational number, you can factor it because it's actually factorable. This is actually a nice method to do if the number simply doesn't make sense. So use b squared minus 4ac to check if that works. And then you just use this formula. Or when you are just complicated by the thing, you just smash it with this. Because this works on every single thing. You can even calculate I from complete the square. You can still calculate the imaginary numbers and etc. And that's about it. That's everything. I've done everything now. Finally, I've done everything on my contract. There's still like a few units that I didn't go through, but that's okay. I don't need to mastery those. I got like a 90 on them or something. Woo!